Hello, hello everyone.
Hello, Alex.
Okay, let me open this. Just open Notepad. Yes, and here. I'm just going to. This one. Yes. Yeah. No. So yes, let's start. Pascal, you want to do the honors?
I can if you like. Okay. So this is our 5th interim for I had in mind 3rd actually. So interesting. Anyway, this is April 4th, but April 1st, but it's still a real interim and it's not a joke. So let's move on. This is an official IETF meeting. So as you're certainly aware of, we have to behave along a certain number of rules, including in particular anti-harassment procedures, which are listed in BCP 25, and patents obligations. So if you're aware of any IPR that applies to a discussion in this mailing list and that has not been described or declared, please let us know that this IPR exists or tell the chairs after the meeting. The agenda for today, we will be talking about seat allocation and rule formats. And then Alexander will present us a new concept of chiclet. So that's quite an interesting concept. Let's see what Alex says. And then we have a discussion about quantum context data compression. Any change, any proposal to do anything?
Yes, so just in the order, I was just thinking maybe it's better if I can present the chiclet first and then the two, like the aggregation rule in a reliability rule format, if it's okay for you. So just change the order.
Perfectly okay. Laurent, you were to present first, so can you stay longer? I hope you can.
Alex wants to start or just to change the order of this presentation?
It's only the order of my presentations. Laurent, you can start. Try to.
Okay, so Laurent will no, Alex. So you have a gap between your presentations, so you can breathe a little bit. I suggest you start with the chiclet, and then we have Laurent. Does it work? So just move the chiclet, which is a 440. Let's move it first, and then we'll do the seed allocation and the SCHC aggregation and reliability rule formats.
Okay. Okay, it works for me. Yes. This way, yes, I'll breathe a little bit.
So you can drink it in between. So there is nothing much new. We have, since the last IETF, actually, we have published an architecture where we still have a little bit of discussion on some terms, in particular payload, which is being discussed on the mailing list. Probably we'll call the SCHC payload the SCHC stratum payload. I've not seen anybody complaining, but be aware that there is discussion between myself and Carles. And if you disagree with the proposals on this discussion, it's a good time to let us know. Apart from that, the documents have not changed since the IETF.
Yes, and just maybe one point here about the. So yeah, well, I'm not going to talk about this one here. Just maybe one point I thought just about right now. The diet ISP ESP people submitted a new version of their draft, and it's using SCHC. So I think that we need to review it so that that they get the feedback. Is there anyone in here that is willing to review it and provide some feedback to them?
Please note that they are using SCHC in an interesting fashion. So I found it quite fun. So it's an interesting read. No one? Basically, Alexander and I have already provided some, and Laurent as well, actually, already some discussion to the diet thing. So we would be looking for somebody else.
Yeah, just one point. We send comments on the list and we never have answers. So maybe we have to organize some work, because during the last presentation we got very nice explanation, which was not so obvious to read in the document. And I made an observation about what is important is how to derive the rule from Ike. if my memory is good, and this is not documented. So I don't know how to proceed to go forward.
You read their last version? They submitted a version during the IETF.
No, I didn't see this one.
Yeah, this is the one I was referring to. So
Okay.
if you can just look it up, and I'll also try to provide some feedback, just so that so I'm not aware if they did all the changes, but like we need to read it again.
Okay, and with this, there are some slides after that, Alexander, that maybe you want to.
No, they were just left over. I wanted to move them in a different place. So
okay, so let me close this deck, and maybe you can open your Sheetlet.
Yes. Okay. So thank you very much, Pascal. So I'll try to be brief with this presentation, and the goal is to get the discussion started, just to see how you all feel about and how to move forward. So there are a couple of documents that I'm presenting today, and all of them are just like ways to say, hey, well, let's work on this. What do you think? And if you feel interested, please just send comments, and I'll be very happy to work together on that. So this is a concept that it actually came to be because of the diet ESP discussion that we had on last time, where the diet ESP people were saying, hey, well, we want to use SCHC, which is the most logical thing, but we don't need all this like complexity that comes with it, which we don't need it, right? And so the idea was to name that thing, right? How do we actually and to probably consider it in the architectural draft. So the idea is to say, well, here there are these things that we call SCHClets, and so yeah, so the objective is to enable the use of the SCHC framework everywhere, where we actually avoid a monolithic approach, which is all or nothing. Like, well, if you want to use SCHC, you need to implement like ACK-on-error, ACK-always, NOAC, and compound ACK, and the rule manager, and like if you want to say, well, I'm implementing SCHC, and you say, well, that like full SCHC is like you take everything that's been produced by the LP1 working group, and you take everything that's been produced by the SCHC working group, like it's just not going to work. We're going to corner ourselves in a very, very narrow use case, right? And here the point is just to say, well, we have developed and we're developing very, very interesting function blocks, let's say, functions. And in the way that things evolved in the, like in chip development, where they had this notion of chiplets, like a self-sustained, it can be an atomic subfunction, like a module, right, of a chip that chip designers use to, well, they take these blocks and they put them together, and this is a fast way for them to design new chips, right? So in this way, we can say, well, we have a SCHClet, and so this is where we make the distinction between like a technology which uses one or more SCHClets. Like, well, they can say, well, it's built using the SCHC framework, right? And it's not necessary to have the full SCHC implementation for that. So SCHClet is a modular atomic subfunction of SCHC as a whole, and it can encapsulate specific SCHC functionality, such as a specific compression, specific fragmentation, or something else, right? And it's self-contained in some way, right? So it implements a specific SCHC operation. We can imagine a SCHClet that works with fixed parameters. Let's say someone wants a very specific compression for their very, very narrow use case, like that. Even the compression context could be a fixed one, like for, and we can say, well, that's a SCHClet, right? You don't have to have like a to support like parsing generic context and generic options and parameters. Like, well, you use like the compression SCHClet, and for your case, it's a very specific implementation of that, right? And the important point is that actually we can have like a full SCHC implementation, and with a specific configuration, it can interoperate with this SCHClet. So just to give a couple of examples, like IPsec compression chiclet. So basically the things that people at the Diet ESP are doing. NOAC fragmentation chiclet. Well, if you want to only use like the NOAC fragmentation, Aconera fragmentation chiclet, or the things I'm going to be talking a little bit more about, but we've been talking also FEC chiclet, aggregation chiclet. And basically, this came from this draft that I was trying I was working on for some time, and like getting this a little bit more modular architecture way of defining like how the SCHC framework and the elements in it work. So probably this thing can be obsolete. I'm not sure yet, but it's basically to say, well, like we have all these chiclets, the compression, and you can have like the SCHC fragmentation, like, and then you can have FEC below it. You can have aggregation, like where we aggregate. I'm going to talk a little bit more about that. Like you can aggregate SCHC compressed messages, and then, well, you know, aggregate and just send one big MTU. Like this can be like a chiclet, and then you can add like a reliability fragmentation, and then you can add FEC to that. Basically, it's providing the tool set of the SCHC framework, in which you can use for like people can use outside of the SCHC world can very easily go and say, hey, well, I need this, and I'm taking just this part. And what we can say is like, well, in any case, this chiclet, it can have like a Yang configuration. So, you know, we may require that people that say, hey, well, I'm using this chiclet, we can say, well, give us the configuration for that, right? And that's perfectly good and perfectly normal, and your code can be very like all the parameters can be fixed in your code. Nothing is loaded within the like, for example, the ISP code. There is no reading of a Yang module or anything, right? Everything is fixed. But on the other hand, we can put a full SCHC implementation, and it can read these parameters, and it will interoperate. And yes, so I feel that, I'm not sure, I didn't say it here, but yeah, basically it can simplify a lot of things. Like people that don't want to talk that much about like stratums and how the different instances can live together and all that, like if they are in a point-to-point, very specific point-to-point scenario, well, you know, they can just use the compression, and we can go back, like in our language, in our terminology, we can retranslate and re-explain. Okay, well, this thing lives in one stratum, and these are how this is how the whole thing works. But from their point of view, like they are using two chiclets or one chiclet, and this is the specific parameters that they're having, and it works for them. So, you know, like it's a very rough idea for the moment, like a very light draft, and I wanted to see how do you feel about it. Okay, so yeah, Laurent on the chat is saying, yeah, in the Yang data model, you can already say, well, I have this feature or that feature. So yeah, that's exactly the thing. Like we can say, well, this device, like this endpoint is having this chiclet is having this feature, and like nothing else. Carlos says, I like the idea. It may be useful for many use cases. Okay, thank you, Carlos. So any other thoughts on this? Yes, so Laurent says this must be the architecture draft. Yes, definitely. This is so the point is for me that the architecture draft is it's like this big thing right now, and I don't want to, like, I prefer writing small drafts that describe some idea, and then once we agree on that idea, to integrate it in the architecture. Right? So Anna says, how to assure interoperability? Well, it needs to like a specific. So if you only have like a compression chiclet that only uses some of the functions there, it cannot be interoperable with something that has fragmentation, right? That's normal. But it's the same way that when we have devices, the device tells you, well, this is my profile. This is the rules that I have, and this rule does this, this rule does that, this rule does this, right? So if you try to send stuff that rule IDs that are not supported by that device, that it will not work. If you try to use parameters options that are not supported by the device, it will not work. So in the same way, well, you can see a chiclet like something that says, well, I'm supporting only this function, only this functionality, these parameters of the Yang thing. And then if you have a full chic implementation on the other side, well, they should be like operating together. That thing should be working, right? Okay, I'll try something. Let's do a poll. Where are the polls? Because how was the no, how was the thing though? How could I make a poll? I forgot this one. Show of hands. Show of hands. So integrate the chiclet the notion in the architecture, in the chic architecture draft. So let's do like a 1 minute. Okay. Well, I will end the show of hands. We have 6. Well, the half of the people saying yes, the other half not pronouncing, but I think that I'll take that as a yes. So, yes, Quentin?
Yes, I was wondering, since the goal now of the working group is to kind of like use Chic outside of LP1 networks, I kind of like believe that what's the most relevant feature of Chic outside of LP1s is the compression. And therefore this yields the question, should we put compression and fragmentation on the same level? Which kind of is the idea of chiclets. You have different features and you tell which one you're using. A different way of seeing the same thing is by saying there is the core of Chic, which is the compression, and there is fragmentation, which is an additional feature, which could be, and so this is just my opinion, we could consider it as being optional. So that's a different way of seeing. Just my 2 cents.
Okay. Well, I mean, thank you. And so there are people that wanted only the fragmentation, right? So that's the way different people see different things. But I think it's just simpler to say, well, everything is like a chiclet and use whatever floats your boat. But thank you very much, Quentin. So what I'm going to do is I'm just going to send an email to the mailing list to get some more feedback if you want, and if you have any considerations or changes or comments on the chiclet draft, please go ahead and can discuss on the chiclet draft. So this way, when we go and merge that to the chiclet to the chic architecture, right? We are going to just take stuff from the chiclet draft and put them in the chic architecture, right? I think it's easier than waiting for everything to get merged and then make like fundamental comments. But that will work as well. So thank you for that. And Laurent, I'm giving you the floor.
Okay. Do you share the slide? Or? Okay, good. Okay. In fact, I was I didn't find my PDF, so I use a very old documentation we made long time ago during Yokohama IETF. So it was a discussion about seed allocation. So at that time, maybe it was too early. And now we have to come back to that, because now the seed allocation procedure is open. And also, it's a way maybe to revisit RFC 9363 that defines the current young data model. So I think we have to open this discussion. I think also that we can now request for a seed block, and even if we have a revision of the RFC, then we can allocate new seeds if there is a change in it. So there is also another draft that is cooking right now with Marco and Quentin. It's not finished, but we will publish it soon. But the results are almost the same as the one I presented a long time ago. So that's why I presented this one. So next slide, please. Okay, so what is important to see in Young? So you know that when we define Young, we define identifiers. This identifier has ASCII character, long strings. And now with seeds, we have a kind of dictionary that put a number, a unique number, to this Young identifier. And this association will last until the end of the universe. So so there is nowadays a way to do the allocation. So it's to first define the identity, like the field ID values, the matching operator. So that's the first part. And in the second part, we have the delta, we have the leaves that are delta encoded using embedded CBOR maps. So during the discussion long time ago, we have this problem of augmentation of a young data model, which means that if we add a new young data model with another range of seed, it will make a large delta in the representation, and this is more costly to send. So maybe we can maybe not go in that discussion right now. So it was a long time ago, but more to see if we can make the RFC 9363 evolve and add new things that will be useful for SCHC, because now we have some more experience on it. For example, we never say in the RFC that all the entries has to be in the user order and not reorder as it was by Young. So here is a specification, it's a new line we have to put in the Young data model, and I think it's valuable to have a revision of the initial Young data model for that. But we can also add new things also in RFC 9363 if needed. So what is important? Anyway, if we have a block of seeds for the new RFC representation, one thing is that and it's possible without any change to what is done right now, is that we have to manually order the seed and not using the alphabetic order. Because, for example, we have rule ID value, rule ID length that are very far away from the beginning of the rule, and we are losing 1 or 2 bytes for that. And if we do a clever assignation, then we can have more optimal model. So it's the kind of things we have to discuss. So next slide. I think it's about this clever allocation. So I will not go into details, but I would like to open the floor, and especially for the chairs, to say, are we ready to request a block of seeds for RFC 9363 and its evolution? So one possible value can be 5,000. So the size cannot be that size. We discussed with Carsten on the list, and I think we reached an agreement of 250 seeds for the block. So here's a discussion open, and I would like to hear your point of view on that.
Yes, thank you, Laurent. I think that we've been discussing this question, and you described it very well for many months now, and we have had several discussions about that. So the first thing is that, of course, and like we've had many discussions on the working group already. So yes, I think that we can request this.
Yeah, I was forgetting. So the other evolution we have is to put universal options in the model, which is something we discuss and looks to have an agreement on the group.
Which were the universal options? Sorry.
The universal option was to say that, for example, if you have a co-op field ID, instead of allocating a seed for this co-op field ID, we will have a generic seed that says this is in the co-op space, and then we put the value that is used by co-op. And if we have another protocol like MQTT, TCP, Quick, or anything where we have value, the group just has to define space ID, and then we reuse the value used by the protocol that makes more interoperability, because there is no mapping between the protocol value and a specific seed defined by the group.
Okay, so maybe can we split the questions in two? Like the first one is like, let's request this block for the seed space, and then the second would be
Evolution of
yeah, with the specific model before we push it to IANA for registration. If it's okay if it's okay for you, because this way we can already start the process, right?
Yeah.
Okay, so I'll use a show of hands again. Start a show of hands. So request seed space for check. Okay, I'm starting it, and
Alexander, we have the same question as before about the architecture, right?
Just one point of the question. I will answer no if you say these values, because I think 500 is too much. So it's more a seed space for SCHC, and I hope it will be 500, but 5,000. But I think it's IANA that decide. So.
Okay. Well, though it doesn't work like this at IANA today. Right? It asks for a young module. So.
Okay, so I vote yes.
I mean, yeah. I see what you mean, and I'll try to figure out a way if we can. How that can. So what you wanted in? Okay. Well, so we have 6 hands. Yes. 0 no opinion. So I'll send the request to IANA and I'll ask if there are ways to accommodate your request, Laurent. To say, okay, well, it's 500 for the whole for the working group, and yeah, and I'll see how we can do that. Otherwise, we're just going to do like extending the Yang data model, and it would look like this. Okay. So that was so it's okay for you for the moment, Laurent? You have enough to
Yes, then we have to discuss the evolution of 9363, and as I say, we have a draft that is almost finished on that, so we can discuss that. But I think it's good to start with the allocation process.
Okay. Yes. So let's do that. All right. So let me then continue with the next slides. So I think I was talking about the so let me start this one. So that's a work. It's been like we've been discussed. I think it's nothing revolutionary, a very simple and basic idea, and it's basically saying, hey, well, we can have we can have a new rule format that is used for aggregation, so aggregating small messages. And here the idea is to be able to minimize the transmissions mostly in delay-tolerant networks, right? Maybe it can have other use cases. And this comes from the observations we did, like for example, in cellular networks, you can have in some cases like the establishment of the communication, and if you need to also have some security handshakes, that can be pretty costly. And if even if you compress the message, then even if it gets very small, well, actually the bulk of the energy consumption comes from all the things happening around it, right? So in this case, it can be useful to actually have some aggregation functionality where we can have like a big message, big packet, which we call here aggregation data unit. Well, it's actually several smaller packets that have been that were aggregated. Right? Like it's pretty straightforward. And so yeah, like as I said, like first it goes through the SCHC compression, and then it's put by the SCHC aggregation in a buffer, and things are aggregated until a specific trigger some condition is triggered. For example, MTU threshold. So like if the aggregated messages become bigger than some threshold, then well, the packet is sent. Or maybe there is a maximum delay. So let's say that you can have like the oldest packet in the queue can be like it cannot remain more than 12 hours in the queue, let's say. So even if you have only one packet staying there, well, after 12 hours it will be sent. But like if you have like 5 or 6 packets, they will be all put in this aggregation data unit, and after the 12 hours trigger is met, condition is met, and then the whole thing will be set in one go. And then you can have like something like minimum packet rate, saying, well, you need to be sending at least one message per hour, let's say. So every hour, on average, the ADU, like the aggregation queue, will be emptied, like if there is anything there. Of course, these are examples. I imagine people can come up with additional considerations here. So it has a pretty straightforward format. So it's a packet format, like you have a rule ID, of course, and here in the nature of in the context, it will be said, okay, this rule ID, it's actually an aggregation rule ID. Then this is the rule ID. Then we have the size field, which is configurable n bits, and then we have like the payload, like the compressed payload, and then optionally the additional ADU segments. And so the interesting part here is that, of course, that you only have you're only going to have one aggregation rule ID, and then inside you have just like size and the compressed field, size, compressed field, size, compressed field. And because the compressed packet is like it's SCHC, so each of these SCHC compressed payloads is going to have its own SCHC rule ID with its own SCHC header. Right? And here are funny things, of course. So what this leads to is, of course, you can like I imagine this like a network operator can configure that and say okay, I'm going to be aggregating like these are the parameters for the aggregation, and I'm activating the unit, and these are the chiclet, and these are the parameters, and then you can have like an energy versus delay trade-off. Of course, you need to handle what if you lose one AGU, then you lose a lot of packets. So how do you handle that? That I don't like it's not addressed here. Also, the buffer needs to be managed in some efficient way. And the funny, like the interesting thing is that that thing can be recursive. I'm not sure if that's useful yet, but at least you can imagine like having the AGU, and then you have like the segments, like the SCHC compressed packets that are aggregated, and then you can have another SCHC compression over that. And for example, if you have all your SCHC segments inside, all your SCHC packets that are there, if they all have the same rule ID, the same and a residue that is very close, we can imagine that a SCHC compressor can actually reduce that a lot. And so it can be, again, aggregated and so forth. So I'm personally against too much complexity, but these are some possibilities. So like as I said, I just wanted to write this up and see if there's any interest for that, or like if anyone wants to take over or wants to adapt it to their own use case. Yes, Pascal?
Alex?
Yes.
The way I would see this aggregation would be that it's a new type of rule, just like we have fragmentation and compression rules, right? So we don't expect that we know what's inside more than, I mean, since it's separated, it just deals with aggregation. There should be something like aggregation rule, format of the train, each wagon in the train being one message. And so from the aggregation rule, you should be able to describe exactly from where to where every wagon is. And once you've done that, you should be able to pull the wagons as if they were SCHC compressed messages. So when you presented things, can you go back to the slides where you have the compressed data? I don't see that we should start with compressed payload data. It's more like first wagon or something, and then second wagon, and then third wagon. If a wagon is a full SCHC message with rule ID, blah 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 blah, what we should see after the aggregation header should be a sequence of SCHC compressed messages which are back to back.
Yes. This is so. But basically, I think that it's so. Maybe I use the not the correct terminology. Basically, I'm not sure if you can see my pointer here, but basically, like you have the application data packet going to the SCHC compression, and then it goes to the SCHC aggregation. But instead of sending that directly to the layer 2 or like the lower layers,
you have to split them. You have to take them one by one.
Yes, and it puts them one by one, like, and it only has like size.
Complaining about I agree with what you said, and what I said was kind of obvious. It's just that your drawing on the previous slide does not show that. Right?
Yes.
Your drawing show that it's like a sequence, or you could make them like different lines or something like a cascade, but it's a cascade of SCHC messages. And the thing I want to know, quote unquote, is if you expect that the aggregation rule ID and whatever descriptor comes after it describes the full train, like message 1 offset blah to offset blah, message 2 offset blah to offset blah, and everything is on the left, the first aggregation header, or if between each wagon you have like a pointer to the next wagon.
Yes, between each. So this is in the bullet, but yeah, you're right. As you say, it reads differently the graphics. So additional, you see the bullet, but it's in the bullet, right? Additional 6 compressed packets are concatenated using the same size plus. So it's not compressed payload. Sorry. Yes, it's the size. So it's like the size plus the SCHC, the output of the SCHC compression. Not go
And
there.
the size is in bits or in bytes?
So I put it in later in L2 words, just to be consistent with the
Yeah,
fragmentation.
yeah. So everyone is padded.
Yes, it can be padded. Yes. But I mean, like it's as I said, like I was feeling that this is like a very obvious idea, and everybody has been talking a lot about like. I think
It's just a matter of having. I mean, it's quote unquote easy to do. We have just to define how exactly we do it. And if we have a real constraint on bits, it could be better to have the full descriptor at the very beginning, and then all the bits completely concatenated one to the next.
I would love to see optimizations like this, and I would love to hear like people saying, yeah, that we really want this, or like, okay, well, there's the simplest thing. But I'll be very happy to work with that, Pascal, with you. Laurent, you wanted to say something?
Yes. I don't know if it's exactly the same, but we are working on a quick compression. And in quick compression, a quick message is composed of different frames. And we don't know exactly how many frames we have. So we solve this in a different way, is that we have what we call also aggregation rules. But say, for example, this is a rule with only one frame. This is a rule with 2 frames. This is a rule with 3 frames, etc., etc. And then we consider the payload as variable fields. And so we use the variable length, the length that is put in the variable, to say now we have this of X byte just after. And this way we can also carry different quick frames in a single PDU. So maybe we have to align and discuss on how to solve that.
That sounds like a great use case, Laurent. Let's look at it. Okay. So yes, as I said, I'm going to put all the MDs, like the sources also, so everyone can contribute to that. So thank you for that, and continuing with the last presentation, or almost the last presentation, but I'll try to do that briefly. We've been discussing that we've been working with Carles on this one. So I'm just continuing the presentation flow, but we discussed all of the questions here together. And as I said, of course, there are still a lot of open questions, but I think it's important that we get this here, the discussion here. So the idea is that in SCHC, small messages, and small messages, that means less than the size of an MTU, are they're penalized compared to big messages that get fragmentation. So big messages that get fragmentation, if we use ACK on error or ACK always, like we know that they're going to be acknowledged. So they really have they have a much better quality of service thanks to SCHC. Another use case is with no ACK. Actually, no ACK. It can be a problem if we cut them. No, okay, I'm getting ahead of myself. So that's the main point here. So that's one thing. And the use cases for that is the first one is smart gas meters, where we can have like high density deployments. So the downlinks needs to be used sparsely, and like the messages can be small. So these smart gas meters, they can actually use, like they can benefit a lot from FEC. So that's good. But also like it's good to know, okay, well, I'm missing some of the messages, like I don't need 100% of my messages to be recovered. But like there are these considerations there. And how do we solve that? Well, we have a lot of very interesting, very good state machine and very good mechanisms already with the fragmentation presented. Right? But it's maybe an overkill to enable a fragmentation for each of the messages. That doesn't work. Another use case is as we can call them, networks that with challenged bidirectionality. Say some satellite connectivity. There are IoT constellations that we can much more easily send uplinks compared to downlinks, and these are not the only such technologies, right? And so there has been already this idea that was discussed and presented in the draft Aguilar-Schick streaming, where we basically have this notion of, okay, I have streams of data, and like I want to acknowledge everything at some like I want to ensure that these small messages are acknowledged in some way. But there's a subtle difference here. So here the proposed solution is actually to reuse the fragmentation modes that are found in RFC 8724. And we use two of them, only two of them for the moment. One is NOAC and the other one is ACK on error. We tweak both of them a little bit to make the rel NOAC, so reliability based on NOAC, and rel ACK on error, reliability through ACK on error. So I'm going to explain it. It's fairly simple. But one thing to keep in mind is that once we have this, if we add also the FEC, so the FEC fragments, so if you remember, like we have a fragmentation ongoing, and from time to time we send FEC fragments with that fragmentation. So this actually allows us to recover, like if some of the fragments are lost, well, we can recover them thanks to this FEC. Well, here we can combine this reliability layer with the same FEC technology, right? So we can recover isolated small messages. So the packet format is the following. We have the rule ID, like the same flags and the same things that are in RFC 8724. Then we have a size field again to say like what's the payload, and then the payload. And the payload is actually as in the previous presentation, it is the output of the let's say the Schick compression, right? But it can be another Schicklet, right? It is the PDU that gets from the upper layer. And so the way it works is for NOAC or for ACK on error, like each individual message comes from the upper layer. Then it is put in a fragment. The fragment is sent to the receiver, and the receiver delivers that fragment immediately, like it's a separate message. On the Schick link, it's seen as a fragment, but like it's just individual messages that are in each fragment, right? So that's the way of operation, like in 2 seconds. And basically there's only one session. Like there is one session, it's like it's maybe opened once, or it's even from the start like considered as open. And that session is like the fragments that are exchanged, they're part of that session. So the windows are wrap around, it's never closed, so all one is never sent, all one messages. And basically you can recover only as the number of messages that are within your window. Like it's not something that can provide you with reliability, with infinite reliability, right? If you have a window size of, I don't know, 16 messages, well, you're going to be able to recover like the past 16 messages and nothing more, right? But and here is also this idea that you can have something like a parameter that is a threshold that says, well, you know, like I need only to have like 90% of delivered messages. So like even if you lose 10% of your fragments, the receiver basically in ACK on error mode, the receiver is not going to send hey, well, you know, I need to recover these missing fragments. So this is the rough idea. Again, the point is to like there are things to be discussed, like every message is sent from the sender to the receiver, then to the upper layers. So what happens if the receiver sees that, hey, I'm missing this message, or I'm missing this fragment? Should it wait for it to be recovered, or should it send immediately the message that it received afterwards? So that can be a configured thing, like send out of order or send in order. But as I said, like the basic idea is reusing everything that we've done in RFC 8724, tweak it a little bit, and use that for individual messages. So, do you have any questions, any ideas? Any suggestions? Nobody's saying anything, so it was either very clear and everyone agrees, or it was not that clear, so you know, it's it requires some time to see. Okay, so if you're okay with that, I suggest that we stop here with this presentation, and if you have any comments or any additional questions, you know, don't hesitate to send on the mailing list, and we'll be happy to answer with Carlos. And for the final minute, we received almost an anonymous submission. So it's a little bit strange. It was actually all the authors of it, everyone, past, present, future, born and unborn participants of the working group, of the SCHC working group, collectively crystallized this thing, which is the quick SCHC, the quantum context error compression, and I was the collapse observer of that. So it's pronounced quick SCHC, just to make things more clear for everyone. And the idea is that actually we can represent all the context compared to SCHC. The point is that all the contexts are in superposition. So whenever you send a packet, a compressed quick SCHC packet, well, the receiver receives all possibilities, and upon observation, it collapses to the thing that really needs to be received. Due to the nature of quantum superposition, any quick SCHC packet contains all possible packets simultaneously, right? So,
Alex, I'm sorry, that's so good, but you made a slight mistake. Look at the title.
oh. Well, you know.
Yeah, that was good.
Okay, let me move just to the applications, because applications are really the most important part. It is so it is designed for extreme constraint and quantum aware environments. Most importantly, interplanetary LoRaWAN deployments, avian quantum carriers, and Schrödinger cat door telemetry systems. And I just want to know that because of the fundamental physics of who is the observer collapsing, we know now who collapses the wave function in all this quantum world, and that is the IETF consensus mechanism, which is observed by the chairs. So we can basically predict when our universe became what it is today, and that was the first IETF meeting in January '86, and we can predict when it will end. Right. So just wanted to say that we we are going to be making a hackathon in Madrid about this by quick SCHC. So bring your quantum computers with you. And with this, thank you all very much.
Adoption?
Adoption, yes, adoption. Let me start let me start a show of hands. If you want to adopt quick SCHC as a working item, let's see a show of hands. I think that our AD will be very happy to see that the things in his working group, in this working group, are advancing well. Oh, it is great success. So we'll confirm on the mailing list. Thank you very much. Thank you all. Have a nice day.
Thank you, bye-bye. And very good slides. I told whom for the quick sheet.
It's the working group. The working group did crystallize. Like it. I was only the observer. It's like quantumly perceived.
Okay. You all take care, and we discuss again in 2 weeks. Bye-bye.
See you. Bye.